thank you, Ottmar, and thank you for inviting me to this workshop here. I'm very glad to be able to present on why finance ministers may favor a carbon tax, even if they do not believe in climate change. And I'm going to present to you some new model results that I hope will explain to you why this is the case. So let's start with some general observations. As you can see here, for OECD countries over the last decades, there has been, beginning with the 70s, a decoupling of receipts and outlays. This means that governments have been spending more than they have been generating using taxes. And part of the story and part of the explanation is capital mobility, which leads to tax competition and tighter budgets. And we can see here how since the 90s, for EU countries, corporate tax rates have been falling. Now this leads us to, on the other hand, as the news always every now and then reminds us, there is demand for public expenditures. So these tighter budgets due to capital mobility are a problem when governments have faced the demand for infrastructure expenditures or public health, education, etc. So this leads us to our research question: can carbon taxes finance infrastructure more efficiently than capital taxes? And with the conceptual model of this in a stylized fashion, we find that in the Nash equilibrium, carbon taxes are in fact more efficient than capital taxes. And part of this, the underlying mechanisms are that capital taxes are subject to the well-known race to the bottom. And the carbon tax has the advantage in this model that it can capture part of the hoteling rent that is initially allocated to the fossil resource owners. Further, a finding that we can come up with is that more inelastic demand for infrastructure also implies that this advantage that the carbon tax has is more pronounced. And finally, because we look at a dynamic model, we see when we look at the timing of resource extraction, that the use of carbon taxes in the Nash equilibrium actually postpones resource extraction, so we do not have a green paradox, but in fact, in the Nash equilibrium, carbon taxes here pose a viable policy option. Now let's look at the model. The basic unit here is of a national economy is the representative household, and the representative firm household rents capital to the firm and receives a return on this investment. And then there is, on top of that, a government interacting with these agents by setting optimal endogenous tax rates, collecting tax revenue, and this tax revenue is then reinvested in infrastructure which is provided to the firm, which uses this to produce output. So the game structure for this part of the model will be that the government is a Stackelberg leader, so it is, we assume that the government anticipates the reactions of households and the firm. What does this mean in terms of the mathematics? The household maximizes its intertemporal welfare, and we have a Ramsey growth model that is underlying these dynamics. So households choose between investment and consumption, subject to maximizing intertemporal welfare, subject to its budget equation. The firm maximizes its profit in demanding resources R and capital K. Profits are output, which it produces with capital G, the infrastructure, and R, the fossil resource. And it also has to pay for capital, a tax on capital, and for the resource as well. So on top, the government, we have a benevolent government. It maximizes also its objective is also to maximize welfare of the household, but it chooses tax rates in order to collect revenue, to finance infrastructure, and possibly to transfer tax money back to the household's budget equation. But this is only the national economy. In fact, we are modeling an open economy, a world economy with two symmetric countries, plus a resource exporter which does not belong to either of the countries. You should think of that as a resource exporting cartel, maybe like the OPEC. These countries are connected on the one hand through the international resource market, where the resource owner sells, the representative resource owner sells the resources, and the two firms buy these resources. but there's at the same time an international capital market where households can invest and then firms can demand the capital. The resource exporter has an intertemporal optimization problem, so it maximizes the stream of its profit discounted by the world interest rate. At each point in time, we assume that the resource market has to clear, and we also assume this for the capital market. At each point in time, sum of supply has to equal sum of demand. Now, how do we solve this? There's a dual game structure that I want to highlight here. We solve for the Nash equilibrium, and there's an asymmetry between, as I've mentioned before already, there's an asymmetry between these several agents. We assume that the governments on top, they anticipate how the rest of the economy reacts. So there's a Stackelberg game in this sense. Each government anticipates how the firms, the resource owner, and the households react in choosing their policies. The two governments interact in a simultaneous move game. This means that they take the policies of the other government as given and do not anticipate any reaction. So we have a dual game structure. On the one hand, a Stackelberg game. On the other hand, a simultaneous move game. And this is, because of this relatively complex game structure, we solve the model numerically. And for time reasons, I better skip the details. You can ask that later about the production function and the parameter values. And I would like to skip right to the results. And result number one is when we look at the output, the model output and some macroeconomic data, that when governments use only the capital tax, then the net present value of consumption is less than in the case when the governments use only the resource tax. So this is also the case for private investment and infrastructure investments. It's the other way around for these last two bars, where we can see that the expenditures for resources are higher when the capital tax is used. They're lower when the carbon tax is used. And this is due to the fact that the carbon tax is actually, in fact, can be used to appropriate a part of the fossil resource owner's rent. So you might say, okay, you've compared the case where there's only the capital tax used by both governments or the case where there's only the resource tax used by the governments. We've also run an experiment where we allow both governments to use both the capital tax and the resource tax. And as you can see in this graph, over time, the tax revenue collected with the carbon tax, tau r, is positive, whereas for most of the time, the revenues collected with the capital tax are in fact negative. So this is because the carbon tax is used to appropriate part of the fossil resource owner's rent. These revenues are used to finance infrastructure, but at the same time, they're also used to subsidize capital. And this is an indication for the race to the bottom in capital tax rates. Even in this case, it's even a race below the bottom, because governments compete for mobile capital, so they try to make their country as attractive for investors as possible. The next finding concerns the role of infrastructure, and we've performed a sensitivity analysis for the parameter of the elasticity of substitution between private capital and infrastructure. Again, we compared the cases where there's only the capital tax used to finance the infrastructure or only the resource tax. And what we can see here, if the elasticity of substitution between capital and infrastructure is relatively high, the difference in the net present value of consumption for the whole time horizon is relatively low. So if capital and infrastructure are good substitutes, then the need for tax money is not so high. When we decrease the elasticity, so if capital and infrastructure are more and more complementary, also the demand for infrastructure will become more inelastic. And this is where the advantage of the carbon tax becomes more pronounced. And yeah, so we see the advantage is more pronounced. So the final result concerns the timing of resource extraction. And this is about the green paradox. First, we see here the extraction path over time for the case when only the capital tax is used by the governments. When we instead look at the time path of the extraction for the carbon tax, then we can see that this extraction path is in fact postponed. So the exact opposite of a green paradox happens, and the reason for that is that the growth rate of the carbon tax when it is used is always less than the market interest rate. And you can, and Ottmar Edenhofer and Matthias Kalkuhl have already analyzed the hotelling model and shown the calculations why the mechanisms of this phenomenon. So let me summarize. In the numerical model that we've implemented, we find that carbon taxes are in fact more efficient than capital taxes to finance the infrastructure. This is mainly because there's an asymmetry between capital and carbon taxes, carbon as a tax base. Only the resources give rise to rent, which can be acquired with the carbon tax, and the capital tax has this disadvantage. Further, the inelastic demand, the more inelastic the demand for infrastructure becomes, the more pronounced the advantage for the carbon tax is. And finally, if we implement the Nash equilibrium, then the use of the carbon tax will actually postpone resource extraction. This is different if we, for instance, look at a cooperative solution, but this is not part of the presentations due to time reasons. And with that, I'd like to conclude, and thank you.